Hi, so I'm just gonna make a quick video so that we are all tracking on the same page. So this is the final result for the circuit breaker analysis for design 1, and it is correct because I validated it with the teacher. And then I still have to make a table for the cost and all the different requirements that they want us to consider if to decide if a design works or not. But I just wanted to show you guys, the ones that don't know how to use Excel, how this can be done very easily and very fast, so that if you make a mistake, say here, and you fix it here, it's going to fix all your calculations all the way down. So there's a little legend, and let me just tell you what this legend means. So we have the resistor. For some circuits we have a resistor. So this one actually, we really are not going to use this legend because the resistors then consumes power, but I'm probably going to take this out. But let's say this one. So you look at this and you know this is watts. So this is real power, which is the power consumed by the resistor here. Then you look at this, and this is VAR, volts amps reactive. So that's your Q essentially for this bus. And then this is VA, volts apparent, and that's your P. Sorry, that's your S, your total power for this bus. And so that's how the legend works. VRMS is for AC currents. So this is RMS, this is RMS, this is RMS. And then here we have DC currents. So this is just 48 volts. And you see how it's a lighter in color. And then the last thing that you want to look at is these are the currents that flow through this particular branch of the circuit. And so these are dark green, which means that they're RMS, which means that this is in alternating current, and so they're a little bit darker. And then the lighter ones are for the DC current. And then a lot of people don't know what the circuit breaker percentage is. Let me just show you. So the circuit breaker percentage comes from the fact that we have to check if the circuit breaker is rated between 10% and 100% more than the current that's flowing through that particular branch. So how do I do that? Well, I take the rating of that circuit breaker, which is in the handout. So if you look at the handout, I think I have it for here. So if you look at the bottom of your design, you have the rating for each circuit. That's for each circuit breaker. So you look at that rating, and then you subtract your actual current here, and you divide by the current and multiply by 100, and that gives you the percent by which you increased this. So this circuit breaker is rated at 28% more than the value of the current flowing through this. And since one of the project requirements is to be between 10% and 100% more than the current that flows through a particular branch for that particular circuit breaker, then this meets the requirement. And so this is 28%, this is 37%, this is 62%, so on and so forth. Now let me show you how to do it, how to get started. So I've already made this for design 6, for whoever wants to take design 6. But say you want to know how to do this. I start from here, and I kind of just draw it out. So say I have load H. I'm going to select 3 cells. So I click on it and I drag it. And then I'm going to put light gray. And that gives me my 3 right here. And then I can just double click on 1 and write load H, for example. And then if I want to make a wire, let's say I'm going to select those 3 by dragging and then clicking on here. And that's how you make the drawing, and you keep going till you have the actual drawing. I like to label at the top of each branch the circuit breaker that's going to be related to that. So say this is circuit breaker O, like there. And then obviously you can use these to center and then click on here. If you click on this drop down, it'll tell you the different colors you can choose. We're choosing light gray for neutral things. And then here, say you're going to have the circuit breaker percentage. What you're going to do, well, let's just do it for the first one. So say I have a load H. So I'm going to look at load H. So this is how to do it. Then I can select all and delete and then put no fill because I already have it over here. So that's how you make that. So this is how you're going to do the analysis. So you start with the load H. Here's the load H. So that's right here. And what do they tell us about load H? So for that, you need to get and I'm just gonna copy it and paste it over here. You need to get this table, which is on the project handout, and go to load H, and it says that you're gonna have 25 amps. So your current is gonna be 25, and now my current is DC because it's coming from a DC bus, and it doesn't say ARMS. So that means I'm gonna use this light green color. So I go to the drop down now that this is selected, and I click on that light green, and I got that 25, right? So now what else are they giving me? Well, they're giving me 24 volts DC. That is for the bus. That's this bus right here, which corresponds to this bus right here. So at the top here, I'm gonna double click and I'm gonna write 24. Then what I'm gonna do is I'm gonna go back to the legend and see that DC is the light blue. So I click on it and there it is. All right, so that's the light blue. And now what can we find? That's the main question of this project. What can we find with these two? Well, I have the current and I know power is gonna be P times V. So use your equation sheet. So you double click on here, and then if you wanna do operations, you click on the equal. That tells Excel that you're about to use the calculator function of it. And what do you wanna do? Well, you wanna find the power used by this load. So that's I times V, current times V, voltage. So what was the current? Well, it's right here. So now that we select an equal like this, then notice how I have this plus and I can select any cell. So I'm just gonna click on this 25 cell and I am going to multiply it, so with the asterisk, times 24, because I know here we're gonna have 24 volts. Then I press enter and nothing happens. There you go. And you get 600. So you know that this power, and this is real power, because remember the current was real and the voltage is real. So I go back here and the real power is in watts. So I use this color right here. And now we know that this load consumes 600 watts. Then we keep going this way. And so now we're looking at the circuit breaker O. And this is where you get the circuit breaker percentage. So the circuit breaker for this particular design, and remember it's different for every design, the circuit breaker O is 35 amps. So that's rated at 35 amps. I want to find the percentage by which the circuit breaker is increased with respect to the actual current that we have. So what I'm going to do is I'm going to press equal so that I tell the Excel that it's going to use the calculator function, and then I open parenthesis and I'm going to do 35, because this is O, 35 amps minus 25. That tells us how much extra current the circuit breaker is willing to tolerate. And then we divide it by the actual current. So we get the extra current over the actual current as a decimal, and we multiply it by 100 to get a percentage. And that means that this circuit breaker is 40% higher than the current. So it's able to tolerate up to 40% more current. And in our project, we're deciding between 10% and 100%. And if it's above 100% or below 10%, then the design has failed. And by the way, as soon as you find a failure in the design, note it, write a note or something, and then move on. Don't keep analyzing that design. So this is circuit breaker percentage. So that's this color right here. And so you keep going, and don't worry about the aesthetics. I will fix everything for you, unless you know how to do it. Like for example, you can take out the view, you can take out the grid lines here if you so prefer, and then you can make, I can draw all the borders. Like here you draw a border, and let's say I want to draw a border here and here and back up. So don't worry about that, because unless you want to. And but this is the important part. And then you keep going. Now, caveat, remember that when you are in AC, you need to find, for each load, you need to find the P, you need to find the Q, and you need to find the S. So say we're doing an AC, let's see. This one, for example, is AC. So what do we know about load C? Cabin lighting, VRMS, so we see it's AC. So they tell us 6 kilowatts. That's the real power. So I'm going to write here, and I always put it in watts. So that's 6,000 watts. That's my actual power. So that is in this color right here. That tells me the units. So that would be this color right here. Now that I have that, and I think I'll have to fix this because I don't have enough space. Oh, and by the way, here's how to do that. So you select, then click on Shift, and then select the last corner, let's say, of the things you want to shift, and then you bring down the whole thing, and it'll bring you down everything, including your calculations. So that's pretty neat. So now I need, what do I need? Well, I need S, right? I need S. And so how are we going to find S? Well, they give us a power factor for load C. Load C, power factor, 0.8 lagging, which means Q is positive. So well, you can do either algebra on a piece of paper or think about it in your head. The S is going to be bigger than the P. So I have to divide by 0.8. So I'm going to say equals, select this cell, and divide by 0.8. And that's our S. So that's going to have this color right here. And it's in volts, amps, reactive. So, sorry, it's in volts, amps. And then we can find Q. So how to find Q? We're going to do equal, and we're going to do the square root. So that's square root. You can select this, and then you have square root, open parenthesis, and you're going to have S. So your S squared, and this is how you would write square for that cell, minus your P squared. So minus, select this cell, and then square it. Close the parenthesis for the square root, press enter, and that is your Q. And we are going to put this as this color right here. Now that you have all of these, you need to find the same for these. So here you also need your S, P, and Q. And then you need to take, say I want to find the P for this bus, I need to add this P and this P. And then I need to find, and then if I want Q, I need to add this Q and this Q. And then to find S, don't add these two up. You have to take this and take the square root of your P bus squared plus your Q bus squared. That allows us to know the S for this. And why is that important? Well, because then you know the voltage from here. And if you divide by the voltage, you get IRMS, which is your current that goes through here, which then allows us to find the circuit breaker percentage here. And you keep going and going. Well, I hope this gets you started. Then another thing that they want us to do is you want to look at the report. And at the end, it tells you these requirements. It tells you what each circuit breaker costs based on the on how it's rated. So this is not a percentage, just remember that. And then they tell you the volume for these as well. And we have to make a different table, which I will do, and maybe I'll do another video for it. Make a different table here to analyze all these things. And then you go back into this and you analyze the proposal. So each one of us should do a proposal for their design. So go locate that for your proposal and see if it meets all requirements. The requirements are listed over here, right here. Here are the requirements. That's why we're doing the circuit breaker percentage. And then the other thing you need to look at is this. So this is how much load that DC-DC converter can support. So say I go to my design here. This is let's say this is a DC, let's see, I actually have it right here. DC-DC1, that's this one right here. And that would be this one, DC-DC1. If I look at this one, this has 1,196 watts passing through it. If it's rated for 1.5 kilowatts, that's enough. So this is below that number, so that's good. If it's rated less than this number, then that's a failure. Well, I hope this gets you started, and let me know if you have any questions or everything else. Unfortunately, I probably don't have a lot of time to meet in person this weekend because it's very, very hectic. But I hope this gets you started, and then just just let me know if you have any questions. Stro, obviously you're in my squad, so just knock on my door, whatever. And yeah, I'll probably, and then as soon as we have this, we can start writing the report. And that's it. Well, we'll touch base by Teams. See ya.